Hi, I'm a software engineer from Denmark and I would like to show you a polyphonic guitar tuner. So this idea about this tuner was born some months ago when I went to a small concert where one of my friends is playing the guitar in this band. He spent several seconds trying to figure out which string was out of tune, and the rest of the musicians was waiting for him. So after the concert I went to him. I proposed that we could investigate a bit in making a polyphonic tuner instead, so he would be able to detect instantly which string is out of tune. The target is here that we would like to have standard equipment like this guitar with a single pickup system, and from this single signal being able to make this polyphonic tuner. So one of the problems is that we have some kind of collisions in the frequency domain where overtones or harmonics from the low-pitched strings kind of collides with the fundamental frequencies of the high-pitched strings. So to illustrate that, I have made a small application. So first of all, I would like to explain how the system actually works. So my system consists of a standard electric guitar, and I have an audio interface which is connected to the computer, and I have a graphically user interface, in this case showing the frequency contents of the guitar signal. So if I, for instance, plug the high E string, we can see that the fundamental is placed on the yellow line, showing that it's in tune with the high E. On the x-axis we have frequency in hertz, showing the numbers from DC up to 700 hertz, and we have the 6 loose guitar strings from the deep E to the high E. So what happens if I plug the E? We can see the fundamental of the E, and we can see the second harmonic. And when we plug the A string, we can observe that some of the harmonics actually collides with the fundamental of, in this case, the high E string. So when we want to detect the exact frequency of the high E string, it's a problem that we have such high level at this frequency from the overtones of the A string. So nevertheless, I actually managed to separate these strings, and I will show you an example of another algorithm that illustrates that. We can now see we have 6 different colors showing deviations from each string. So if I plug all the strings, we now have estimates coming out showing that we have a guitar almost in perfect tune. So if I adjust the high E, you can see I can move it up and down. We have the B string, we have the G string, we have the D string, we have the A string, and finally the low E string. So this is proof of concept of this polyphonic tuner. So in this display we now see on the x-axis we have the strings, low E, A, D and so on up to high E, and on the y-axis we have the deviation in cent. So when I plug the strings, we can see that we have some small boxes which moves up and down according to the tune of each string. So if I adjust the A string, you can see that it moves up and down, and so on. The G string. So, and having in mind the origin of the original idea, it was that it would be nice for the artist to quick identify which string needs adjustment. We can make a small example. So if we kind of misadjust the D, for instance. So this is the situation from the concert, and the artist would then plug all strings, and quick he can see that, oh, we need to adjust the D string. and then he is ready to go on with the concert. So I believe that this polyphonic tuner approach is a much more intuitive way to tune your guitar, and at least it's a lot faster than having to tune each individual string. And the next step for me will of course be to investigate a bit further and perhaps even make a small prototype for my friend so he can bring it on stage. I think it's not that realistic to have a laptop along on stage, so a small device that will allow him to use this new technique on stage would be very nice. Thank you for watching this video. Bye bye.